San Diego. Sus trabajos se centran en entender dónde viene el plástico que llega al océano y qué camino sigue, incluyendo el aporte de la industria pesquera a la contaminación marina. Antes de esta etapa, investigó las emisiones de gases de efecto invernadero que producen los plásticos cuando se degradan en el ambiente y colaboró con el profesor Nikolai Maximenko en el International Pacific Research Center de la Universidad de Hawái, estudiando las rutas y el destino final de los desechos marinos, en particular su acumulación en el parche de basura del Pacífico Norte. Durante más de una década, la doctora Royer ha trabajado intensamente en divulgación y educación ambiental, colaborando con organizaciones como Sustainable Coastline Hawaii, donde fue asesora científica durante 8 años y lideró iniciativas de ciencia ciudadana y Compartly for the Ocean. Su objetivo es claro, de que los datos generados por científicos y voluntarios sirven para diseñar mejores políticas públicas y que reduzcan la producción y consumo de plástico. Gracias, Sara, por aceptar esta invitación y cuando quieras, the floor is yours.
Muchas gracias, Laura. Bueno, lo siento, me gustaría mucho hacer la presentación en español, pero creo que sería mejor en inglés. Hace mucho tiempo que no he hablado. He hecho mi doctorado en España, en Barcelona, en biogeoquímica, al Instituto de Ciencias del Mar. Pero bueno, después me he movido en Hawái. Es el lugar donde he encontrado la Laura. He hecho postdoctorado con ella y Nikolai Maximenko. Así que muchísimas gracias, Laura. Bueno, ahora voy a hacerlo en inglés, lo siento. Thank you very much for being here today, and I'll be presenting plastic pollution in the environment. So I will start with a general introduction, just like to set the floor a little bit. So plastic has been created, invented probably in the 80s, but really it started booming in the 1950s. And I'm always putting this image when I give a general talk about plastic because it's quite shocking. Like it made the cover of a Life magazine where basically like disposable items were like such a big hit, and it was like a throwaway, like living. It was a big culture, and the idea was it will free up a lot of time for housewives that won't need basically to do dishes after dinner. So it was like such an interesting perspective back in the days until we started realizing then, okay, um, what's actually like the full impact of all of this plastic. So now the numbers have increased by a lot. So globally, we produce 380 million tons of plastic each year. And something to note, then it's actually cheaper to make new plastic than to recycle it. So I'll get back to the recycling a little bit later, but that's something to remember. So the numbers, as you can see, since the 1950s started increasing tremendously and are still projected to get even higher with the years to come. Plastic is durable, it's convenient, it's cheap, and that's why it's everywhere. Um, it's like in our like products, in our food, in our like basically we all have like wearing or using plastic on a very regular basis, pretty much at every minute of the day. And as a result, plastic is everywhere. Like it can be found in all of this different strats of the earth. So which is really sad. In average, every minute there's one garbage truck of plastic that's dumped into our ocean. And here on the right, I put a picture of a beach I'm working on. So that's Camilo on Big Island. It's the south of the island. And this is the trash that we see there on a regular basis. And it's not even coming from Hawaii. It's actually like pollution coming outside of the island. So 95% of the trash we find on Hawaiian Islands are coming from outside and has traveled a lot. So not to blame anyone else, just like to give an idea of how plastic has no boundaries and it can be found everywhere, even on the most remote beaches of the world. So the type of debris that we can find, actually the top left, it's actually fishing lines. And this was found on the same beach as the picture before. Then on the bottom left, these are microplastic that we sift here in Hawaii just to try to remove the small particles. Laura got the chance to come with us to do a little bit of work on our beaches. On the top right, it's actually one of the most polluted river in the world between Guatemala and Honduras. So this is all basically plastic bottles, so single-use plastic items. And the bottom right, these are microfibers that we don't see with the naked eye. So you can see the variety of type of debris that basically we have. The fate of plastic and the global perspective. So here, the primary production, let's say it's 8,300 tons. And then just to redistribute this, we currently use 2,500 of this plastic. Then there's only like 600 that's being recycled. And again, recycling is not the solution. It's very expensive and it takes a lot of resources to do so. So even though we may think when we use products that a lot of this product that we put in the blue bin in recycling is going to be like reused and like transformed and have another life, the quality of the plastic doesn't remain the same when it's recycled. So most of the time we need to put a lot of virgin polymers mixed with it to make it as strong. And then incinerated 800, a little bit more than recycled, and discarded 4,900. So more than half of the plastic is actually being discarded, which is the big part of the problem here. So in 2015, we would expect like to have all of these different trends all going up for like the incinerated, recycled, discarded, and all of the primary waste generated. So we don't even see like a decrease within the next century. So everything keeps increasing. And one of the questions that we had as scientists, that's Laurent Le Breton. So I work for the Ocean Cleanup. I've been working for 6 years. It's an NGO that's based in the Netherlands, in Rotterdam, and we aim at ridding like the ocean of plastic. So we want to remove the plastic, especially starting with the Great Pacific Garbage Patch and between California and Hawaii. And we work also a lot with rivers, so the most polluted rivers of the world, to prevent all of this trash from going into the ocean. And one of the questions that we have as researchers is like find the missing plastic. So out of all of this plastic that's actually like discarded into the environment, when us scientists are trying to understand the different things of it, like where is this plastic going, a high percentage of this plastic is very hard to find. So we would think that, okay, all of this plastic may be found at the bottom, at the surface, and then we create a budget to understand this better. But we still cannot find a very high majority of the plastic that we discard in the environment. So I'm here like looking at a few of the possibilities of where this plastic is going. So the ocean surface for the plastic actually floating at the surface. So with a density lower than seawater, it floats. Sediments, so the plastic that sinks. Then marine life, sadly, the ingestions of plastic by marine life. Then the marine snow, and then you have nano and pico particles. So when it fragments, it becomes smaller and smaller. The water column, the re-beaching events like in Hawaii. So plastic, let's say, goes through a very polluted river, it goes in the ocean, and then it ends up on remote beaches of the world. Then sea ice in the Arctic, in Antarctic, the atmosphere. So we have so many things for this plastic, and this has been like a popular topic among scientists just to understand better where should we act, like where should we spend most of our effort when working on plastics. So, and just to understand in general, like the global like thing for all of this trash. Um, so this plastic, of course, when it's found in the environment, it's going to be affected by different environmental factors. So it's affected by light and UV light. heat and fluctuating temperatures. So the plastic will degrade faster in warmer environment versus than cold environment. Moisture will have an effect, the chemical oxidation, so the oxygen in air, the microbial and biological activities, degradation through biofilm formation, the physical stress also of the wave, for example, wave action, salinity. So all of these environmental factors, they have an effect on this plastic discarded in the environment. The degradation product, so when it actually degrades, we have like a list of like the different degradation products that it can basically create. Oops, I'm sorry. And as we know, plastic is not inert and is known to release additives and other degradation products into the environment throughout its lifetime. So there's a lot of plastic in itself that is inert, but then we add all of these additives in very small numbers, but these are actually the most toxic, and they are the ones that have adverse effects on the environment and human health. So I'm giving an example that everyone knows. It's actually the bisphenol A that is used in the manufacture of many plastic products and that will leak as plastic ages. So, I mean, like plastic bottles to feed babies and all that, they would have all of these different additives that will leak into like basically the milk of the baby, and then the baby will ingest it. And since babies and kids, they are developing their brain at a much faster rate, then it will affect a lot their health. So anyhow, so all of these products that are added to the plastic to basically have a more durable plastic, like with like greater like durability against UV light over time, will be the compounds that are actually really toxic. So most of the compounds reported are additives and stabilizers for this reason. But part of the research that I did in Hawaii, and that research is really close to me, even though it's been a little while, it was such and I was like discovering my passion for plastic pollution while I was at the University of Hawaii, because I used to work like on climate active gases, and I was working on methane and other gases, and my lab partners made a discovery that was about hydrocarbons, and it made a big splash in the field of plastic pollution. So to make the story from the start in itself, so my colleagues, basically Sarah Ferron was working on experiment where she was trying to understand better the concentrations of methane, a very climate active gas found in the ocean and produced by biology. She was trying to understand the concentration in seawater. So she will make all of these incubations with seawater in these bottles, and she would notice that the concentrations of methane were really high, and it was hard for her to understand. As she would let time goes, and like basically the sun being on the bottle, so as she will continue the experiment with time, the concentration would go higher and higher. And at that time, she made the discovery that, oh my God, like these gases, it was not only methane, but other gases may not be coming from seawater itself, but probably from something else. And it was coming out of these plastic bottles. So that was like, this is a big thing, like, so let's change the protocol. So they continue doing their protocol to understand again methane from biological production using like a better means like a glass and a quartz, so that plastic would not leak. But then I came in and I was like, oh my God, this is such a big research. And then I asked my supervisor, can I switch my research topic to this This one basically that will be like the emissions of greenhouse gases from plastic. No one was working on it, and I thought it was like something important and a big discovery. So yeah, so hence I continued working on it, and I worked like with, of course, I didn't work with like plastic bottles, but I worked with quartz wires, and then I tested like the most common different types of polymers, so polycarbonate, acrylic, polypropylene, PET, polystyrene, HDPE, and LDPE, and I would basically incubate them for a certain amount of time and measure the gases that will be basically emitted from these plastic particles. So I was using GC analysis, and I started with methane, ethylene, and I kept on working with different gases at that stage. So basically, all of these most common plastic that we are currently using, they were like all emitting methane and ethylene. So ethylene is C2H4, so another greenhouse gas. And the one that will be emitting the most was low density polyethylene. And low density polyethylene, it's actually the polymer, the plastic that is the most produced, consumed, and discarded in the environment. And it's also the one that's producing the most greenhouse gases. So it's a weaker polymer that can basically like leak these gases easily. So I was like, oh my God, this is crazy. So I started basically working with LDPE and look if the concentration of the hydrocarbon gases will keep on increasing with time. So since we decided to focus on this, so then I just look at virgin LDPE, and with time, this is days on the x-axis, and then the different gases that we studied. So we focused on 4 hydrocarbons. So basically, methane, ethylene, propane, and ethane. So all of these gases, with time, there will be an increase in production. And then we went out at sea, and then I collected some microplastic in the ocean using a manta trawl. And then I also ran some Raman spectroscopy to see what was the polymer type. So the age one was the one I collected in the ocean. It's the red line, and the blue one is the virgin one. So the same polymer, and then with time I tested the age one. So we don't know how long it's been in the ocean, but we could see that it was still producing in very high quantity ethylene and methane, so the two most powerful of the 4. So I was like, oh my God. So then I started looking at all of these pieces with scanning electron microscopy at UH, and just to understand better, like how do they look from very close. And what we saw, it was basically that all of these plastic particles, they had lots of crevices and holes, and they had a little bit of biology as well. So one of the questions we asked was, does the concentration of the hydrocarbon gases keep the same production rate when fragmentation occurs? So that was the question that followed up. So as plastic fragments and degrade in the environment, what happened? So to mimic that, we use like 3 grams of powder of LDPE and then 3 grams of pellets, so slightly bigger fragments. And we noticed that, I'm just putting here the methane, but there was 488 times more methane produced with the powder than the pellets, which was a little scary. That means that as a single object with the same weight is degrading in the environment. So first, of course, it's a full bottle. Then it starts the creation of pits and microfractures starts without fragmenting. So all of these crevices that we saw with the SCM images, basically it shows that the surface area is much higher, even though it's not fragmented. And then you get the fragmentation of these items. So when it fragments, it booms. It's actually exponentially increasing the gas because the surface area of these particles is so high compared to the bottle. So basically, for the same weight of trash as it fragments in the environment and becomes these small pieces, that's close to my home. Basically, we see this in the water. So all of these small particles with a very high surface area will produce a lot more greenhouse gases than if it will be a whole piece. So yeah, that's kind of scary. So, and then you go out at the beach and you're like, oh, I'm better picking up all of these pieces before they fragment into smaller pieces and produce even more. So that was the third finding. And then we were like, okay, we study a lot like plastic in the ocean, and we all understand the importance and the reason why. But what if we look at the production of these greenhouse gases in water versus in air? And this is where it started being a little scary, because what we saw it was that there was about 3 times more methane produced with plastic exposed to air and 76 times more ethylene, which means that when plastic is actually sitting under the sun, it's going to produce a lot more greenhouse gas than in the water, because the water will be kind of a buffer for the gases, and more, not for the gases, but for the absorption of the UV and the light itself. So then we were like, oh my God. So it means then we no longer treat this discovery as only being like plastic pollution. I mean, now all plastic is actually pollution. So even though like these are items that are not to be thrown away or discarded, a pool in plastic, a playground, greenhouses, houses, and cars, these items, they all emit greenhouse gases at all times. Yeah, that was pretty scary. Then we continued the research. I will not go too much into details, but then we started looking like at the effect of temperature. So of course, as temperature will be increasing, more gases will be produced. Then we looked at night production. So we may think that during nighttime, there's no more production of gases. But once the process has started, the gases started being emitted, they will keep being emitted. Even during nighttime without any UV and sunlight. It will be a slower rate, but it still continues. So if you put your items outside in plastic and then you bring it in your home, it will keep on producing all of these greenhouse gases. So that's something to think about. So yeah, basically that was like the last part of our research on that specific paper. But now, of course, I mean, there are a few groups that are still working on the topic and trying to understand better, like the importance of studying these compounds being emitted once plastic is basically exposed to sunlight. I studied these four gases plus CO2 and CO, so just 6 compounds, but there are like thousands of compounds that are being produced because of the stoichiometry of these plastic molecules when plastic is out there. So we just studied a small fraction of it and we could see it makes a difference. So that's something that needs to be further researched, like always in science. But I thought that specific topic was very interesting, and especially like trying to understand better, like how much plastic on Earth is currently being exposed to the environment. And this is a tough question because for the ocean, we have good estimates, but then it's a little harder to get good estimate like for the land itself. So in terms of trash everywhere, but also in terms of plastic in use that are not trash items. So I think the next step is really to look at the total amount of plastic that's exposed to UV light. And then we need to get a better understanding what are the polymer types, because we saw there's a difference between LDPE and PP, like different types of polymer. And then we need to understand the surface area. So as plastic becomes smaller, it produces more. But then we can't expect satellite to be able to detect smaller items. So we can see from space like a big fishing nets, but we cannot really see a bottle cap. So we need to find like better ways of having a better idea of how much trash is out there and what's the total contribution to climate change, basically. So that was the research that really got me into plastic pollution like 10 years ago. And then I kept on working on more invisible sources, I guess, because we don't know. But I mean, the gases, it's invisible and it's a little harder than if you work like with wildlife being entangled. And I was really interested into that. So I moved to Scripps to work on another project, and that was plastic pollution in the textile industry. So I started working like on microfibers that are like basically 1/5 the diameter of a human hair. So it's about like 3.4 microns. And then it ranges anywhere from like 17 to 180 microns, like in length. And it's invisible to the naked eye. So these microfibers, they are actually being detached from our clothes while we wear them and also while we wash our clothes. So, of course, here, like we have all of the visible part of it, but if we start thinking about microfibers itself, they are so tiny that we don't even notice them. And they are generated and they are there all the time around us. So that's really something that's needs to have like further research being conducted about it, because 62% on average of our clothes that we wear are made out of plastic. So here I put a few numbers, but basically, like if you look at this is the orange line, the clothing utilization. So it's basically the green line, and then we can see that the clothing sales is the purple line. So we use less and less our clothes, but we consume and we buy more and more. So on average, like an American, I would say, would go shopping twice a week, and one out of the two times we'll be buying something. So it's actually like a lot of consumption. And with fast fashion, like we have the industry pushing us to buy more and more. It's very pressing. It's like you go out there shopping and then you basically like get loud music, bright colors, like there's so much going on, and everything seems to be pushing you to come to buy more and more, and it's almost like a lifestyle. So luckily I was not like raised that way, so I've never been a huge shopper, but it's true that if I go to a store, sometimes I feel like, oh my God, this is like stressful. It's not necessarily an experience that will be relaxing. I don't see this as a hobby, but sadly, I think a lot of consumers will see this as something very exciting, because the industry is pushing us to buy more and more. Anyhow, I could go forever about it. But yeah, these numbers are pretty scary when you look at the amount of trash that's discarded into the ocean. It's one garbage truck every minute. So in the ocean. When you're thinking about clothing industry that we don't talk so much about, it's one garbage truck of textile is being burned or landfilled every second. It's huge. This is so huge, and a lot of that clothing hasn't been used. So the fast fashion is a huge polluter. So that's why I was interested in studying this more. Now there's more and more research, and I'm still very, very interested in hearing more about it. But back then, like a few years ago, it was not such a booming like topic, and I think uh, the fast fashion industry is being a little protected, so it's still a topic that's hard to get outside of the scientific community sometimes. Like if you want to be like, okay, this is really devastating, we need to do something for it, then it can be sometimes a little harder. But anyhow, my research I did was at Scripps Institution of Oceanography at UCSD. And the idea was basically to take different types of textile and incubate them at the surface and at the seafloor. So basically, I had coupons, they were in little cages, and every 7 days, I will measure different parameters to look at the degradation of these textiles over time. I would look at them like physically, I would take measurements, I would look under a microscope, just to understand better, like, are these textiles degrading over time or do they remain intact? And I did also some SEM. So I look at different types. So the first column is natural fibers. So it was a collaboration with Lenzing where we'll be using different types of cotton or viscose modal. So everything that's basically natural. Then I had some synthetic one, polyester and polypropylene. Then I had a blend of both, and then I had bio-based polymer. So the PLA that is actually like supposed to be like a very green solution to replace synthetic material. So basically, I'm just showing you here like all of these different materials at the sea surface with time at day 0. Day 7, you can see it's already biofueled. Day 14, you can see then the top row, it's basically like shrinking in size for the natural one. Day 21, day 28, like most of the cellulose base is gone and the cotton, non-organic cotton is still there. And this is day 231. So that's for the sea surface. And then after that, I did the same experiment with the seafloor. So I would get the same coupons, different materials over time, days 14, day 21, after 1 month, and then you still have a little bit of cotton, and then day 77, and then close to 200 days. So basically, for both the sea surface and the seafloor, what we notice is that all of the natural compounds, they are basically gone after 30, 35 days. And then the blend material here, you can see then half of the blend, I mean, it lost its shape. It's not as clean as it was before, because there's one fiber that's natural and the other fiber is synthetic. So all of the natural fibers are gone, but the synthetic material still keeps the shape. Then you have the synthetic materials after 200 days, it looks pretty good. And then the most shocking was the bio-based polymer. So the PLA, that's polylactic acid. It's actually sold as being like a green solution, basically for a replacement to synthetic material. So they look pretty much the same for the seafloor and the sea surface experiment at the beginning and at the end of experiment. So that was very surprising because I would think that it would start degrading and basically like be similar or close to similar to natural compound, which was not the case. So this was interesting research because at the same time, there was another group of researchers at the University of Plymouth doing similar experiments with biodegradable bags. And the discovery was like it could hold a full load of shopping 3 years after being discarded in the environment. So often, like you have like these, the consumers are being just, it's easy sometimes you just read that, oh, there's a solution for this problem, you can use this instead of that, but I really think that the consumer, they need to have a better understanding of the products they are using, and we need a little bit more research when we use a product. And of course it's hard, like you cannot necessarily study scientifically every like items that you use or purchase, because it's not necessarily like yeah, it just takes time basically, and it's not in the interest of everyone. But it was some shocking research in the sense that I think there's a lot of greenwashing around it. And if you're not curious as a consumer, then you will consume products that you think may be helpful for the environment, but in the end, they are not really. So yeah, that was just a little message here. Yeah, I just finished with that slide. And basically, when you look at all of the sources of pollution, I mean, you have so many different sources and pathways, and in the end, everything is kind of interconnected. And that's also linked to the microfibers, like the microfibers that we have coming out of our clothing. We breathe them, we inhale them, we have a cup of tea, a beer, a coffee, we have all of these fibers that will be falling in our basically glass, and then we just ingest them. So overall, it's 17 grams of plastic that we ingest every week. It's the equivalent of a credit card through different ways. So microfibers is another one, but yeah, we know a lot more now about like the importance of like being careful as consumers. Whenever we consume something, we should be doing it like carefully and think about the products we use just to like decrease that amount of plastic that we ingest on a regular basis. So from like a plastic bottles to cutlery and plastic, and to single-use plastic items that are so readily available. So yeah, here I just put back that image that basically shows then out of all of this plastic that we consume, the discarded amount of plastic in the environment and landfills will be increasing at a very fast rate up to 2050. And here I always like discuss a little bit like also the importance of knowing like the effect of harmful plastic on different like wildlife. And here in Hawaii, we are very much exposed to all of these. So monk seals that will get very easily entangled in fishing nets, turtles. Then we have all of these beautiful seabirds and albatrosses ingesting plastic from a very young age. And then we have lots of habitat destruction. Basically, like our coral reef will have a lot of nets and lines that are being entangled. So it's really, really toxic, and it prevents them like from breeding, like if I can say it this way. So it's something that really affects every single like strat of our planet, which is sad. And every single like in the food chain, like the plastic is so little now. It goes into pico and nano level, and it degrades and fragments at a very fast rate, and we no longer see it like with our naked eyes. So the smaller it becomes, the smaller organism would be able to ingest this plastic. So it's basically being found everywhere. And this is another reason like we should be removing that bigger pieces of plastic so it prevents them from basically getting into smaller items, harder to remove, and also it will touch less of the lower level of the food web. Um, so yeah, and here I have like I just put a slide on like the amount of money that it costs. Marine plastic pollution is insane. Like we don't always realize it, but it's a lot of money that's being put into this, and it affects a lot the travel and tourism industry. And like in general, here in Hawaii, we see like the result firsthand, and it's so tragic. So I guess I'm just saying this because I always end even during scientific conference about like how can we like move towards a better future? So how can we work toward a better future? And I mean, no action is too small to make a difference. So here I'm showing like a beach cleanup with Sustainable Coastlines Hawaii. So basically an organization I've been working with for 10 years, the biggest beach cleanup organization. So basically we do regular beach cleanups. And when we do beach cleanups, I actually study the plastic that we find. And this could be maybe my next talk I'll be giving. But I'm actually studying like 55,000 kilograms of debris, so 55 tons. I just finished basically this month is my last month after almost 7 years of data collection. So I'm trying to understand better the trash that we find like in the North Pacific garbage patch, so the gyre with the highest concentration of floating plastic. And then I looked at all of the debris that's from beach cleanup on the main Hawaiian island. And I'm also studying the debris that we find in Papanumakwakea Marine National Monument. So this is, for example, Midway. I don't know if you saw the movie Albatross, but there's a insanely high amount of trash that beach there, and these are very remote and no anthropogenic activity beaches. So I'm trying to understand better, like where is this trash coming from? What's the most common item we find? And so far we find about, like, on average for these three regions and 55 tons of debris, about 71% of the debris is coming from the fishing industry. So these are things to think about. But yeah, the beach cleanups, I mean, they won't change. Like, it's just to remove the current plastic that's currently out there that we need to remove before it becomes smaller and smaller. With the ocean cleanup, we try to remove all of the plastic from the GPGP, also from the river. So it's just prevention. But the ultimate, like, idea is basically what should we do, like, as consumers. So my number one is always, like, stop using single-use plastic items. These are 40% of the total amount of trash that's being of plastic trash, yeah, that's being produced. And these are so easy to be replaced. Like, it's basically like just using your bamboo and natural cutlery, your tote bag, your bottles that you can rewash, your straws that are more sustainable, and using cloth diaper. She's my daughter there. I'm a little biased, but I'm using cloth diaper. I'm trying, like, to reuse water from rain and just not to consume a lot more water because of that, but it makes such a big difference to not have, like, disposable diapers. Like, a parent will use between 8 to 12 a day, and these are, like, this is a lot of plastic disposable diapers. So there are so many solutions. And then after that, I put my friend Louise here. She's the co-founder of Sustainable Coastlines Hawaii. She's so good. She has a capsule closet. So she has very few items in her wardrobe, and she's trying to make it in a way that she can match easily. She chooses colors that are easy to match with the bottom and top. So this is, like, to be, like, a good consumer. I think something that we have to reflect on is reducing the amount of textile we use, given that a very high amount of it is made out of plastic. Then using natural products. So here, this is a crew that went into the garbage patch and crossed the Pacific on a sailing boat, the Vortex swim. And they all wear, like, merino, so basically like wool, all natural. They wore it for, like, more than a month, the same shirt that you see here. And yeah, it has some advantages because of it has very little smell, so you can wear these almost every day without smelling. So they were completely green on that cruise, on that expedition. And then I always say, like, thrifting is cool. So why not, like, trying to get, like, items that already were used in the past and give them a second life rather than encouraging that mass production of clothes. And at home, we have basically a filter that prevents all of these microfibers to go into our waterways. So then we collect that filter and then we just discard the microfibers. So not in the toilet. Often people, they will remove, like, their lint from the dryer and they will put it in the toilet. I'm like, no, put it in the trash so it doesn't go to the ocean. And then after that, contact your legislators, try to make a difference at another level, because I truly believe that in the end, I mean, we can make a difference as consumers individually, and I think this is wonderful. We should all do that. But eventually, if we have the law and policymakers, like, having bills and bans, and, it's like we used to be able to smoke in a restaurant, and now we are not allowed to do it anymore, and it's because of the laws. So if someone will lit a cigarette in a restaurant, we'll be like, oh my God, this is crazy. So I wish one day it would be the same with, like, a plastic fork or a plastic bottle. It's like, oh my God, this is crazy. Someone is drinking out of a plastic bottle. So I think we need help with that, and we need good politicians to be behind us. So we should not lose hope and just push towards that and shift to a more circular economy. So yeah, that was my last word on the overall presentation. But yeah, I wanted to thank you so much for your time, and please feel free to ask me any questions if you have any. Muchas gracias.
¿Preguntas? Parece que te vas a cargar. Te entiende, te entiende. Te hace la pregunta en castellano y le puedes contestar en inglés, ¿no? Sí.
Sí.
Vale.
Buen día, ¿se escucha?
Sí.
¿Sí? Si en algún momento estudiaste o si decidís estudiar partículas derivadas del desgaste de neumáticos,
Partículas derivadas de qué?
del desgaste de neumáticos.
Tires of the car.
Oh, I never studied that, but what I did in the past, I was very active, like with several groups trying to ban synthetic turf, so it's fake grass. And I'm gonna get to that topic. So fake grass is like in the US, it's so popular. Like all of these fields for like football, soccer, they are all made out of fake grass. And I started being very interested in the topic because these large field of fake grass, you want to have the blades of the grass being lifted up. And then these blades, the only way you can get them like being upward is by putting tires, crumble of tires. So for every square foot, you have about 3 pounds of crumbled tires being poured over it. And these tires, it's terrible because they are loose. So if you have a rain, you get all of these small particles of tires basically being like washed into waterways and eventually into the environment. And even though I haven't studied it scientifically, it's well known that these particles are toxic because they are microplastic, but they also contain a lot of additives and plasticizers that are toxic in general. And it's the same with the tire. The wear and tear of the tires on a road is really high. As we use our cars, we have all of these particles that are getting detached and then they are loose in the environment and they get washed into our waterways and eventually some to the ocean. So something really toxic. And there are some good groups studying this, but I haven't done it myself, unfortunately.
Ok, gracias.
Ah,
Hi, Sarah. Thank you for your presentation. It was really good. I was wondering, your first research, you said that a lot of greenhouse gases are emitting from plastic stranded on the beach. So what about our clothes, synthetic clothes? While we are wearing it, is it emitting any gases?
Absolutely. So our clothes, let's say polyester is the equivalent of a PET, plastic bottles. So polyester is probably the number one that we wear. It's usually like the cheap, like t-shirt that you can get for a couple of dollars compared to organic cotton. That's usually 10 times the price. So all of these clothings that are part of the fast fashion business, a lot of them are made out of polyester. They emit greenhouse gases. And then you have other materials like nylon, lycra. So basically, it's sad, but the clothes that we wear for doing yoga, we actually emitting greenhouse gases, especially if we are outside. So sometimes it's like, oh my God, like we are trying to be healthy, to be good, but there's also a part and the options are not all there. So Lululemon, I mean, it's such a big brand and that's probably the number one for yoga clothing. I just wish at some point they will be making some clothes that are made out of natural material because it doesn't feel right to be wearing clothes emitting greenhouse gases. But yeah, basically, plastic in general, they all emit different types of greenhouse gases. And given that athletic clothes are a lot made out of plastic, sadly, they emit these gases.
Thank you.
Hello, Sarah. Thank you for your presentation too. I have a question related with the ocean acidification and the harmful of the wildlife. Sorry, because I don't know about the solubility of these hydrocarbon gases. So I was wondering if in the places where there is a concentration of these plastics, for example, the plastic island in the great oceanic circles, maybe there is very important organisms like picophytoplankton that you saw some article about Prochlorococcus, and in these places the ocean acidification is increasing, or these gases goes to the atmosphere?
Hey, this is a good question. I haven't studied that per se, but it's true that if the plastic is basically floating at the surface and it emits these greenhouse gases, I would think that usually the sink for these gases, I mean, unless it's really lower in the ocean, it will be emitted straight to the atmosphere. But some of the plastic, actually, if they are floating and then they start emitting greenhouse gases, but they start being biofuel by wildlife, then these particles will start sinking in the water column, and these gases will be emitted in the water, although they might be ventilated into the atmosphere. That's for study, but depending on the regions and like the ratio versus atmosphere ocean. But yes, some might stay trapped in the ocean, some of these gases. But and the acidity will also make a difference also on the degradation of these plastic items and change the emission rate of these gases. So I mean, there are a few factors that will influence the effect, but yeah, I wish I could study like the relationship between the acidification and then the organism and then the plastic emitting all of these gases, but I haven't done any detailed research on the topic. But I did try the acidity, and I saw that there's a difference and there's an increase as acidity increase, then the emissions of these greenhouse gases will also increase. Sorry, I'm not answering totally your question, but I don't know enough about it.
Well, hello, and thanks for the presentation. It was really clear, and I learned a lot. So I was thinking, just to understand a little bit better, how can you compare the amount of gases that a plastic produce with a cow, for example, for methane? How many kilograms of microplastic or big plastic you need to compare with a cow or with livestock or with a car? I don't know. It's how many kilograms or something of plastic?
Yes, this is a wonderful question, and that's the question I was hoping to answer for like 2 years, but it's a big one. So if we take all of the plastic in the ocean that's currently floating, we basically convert it into like close to powder and LDPE, so the plastic that emitting most greenhouse gases. We get about like 1.5 teragram of methane being produced per year. So that's close to biological production in the water. So I studied that part, but given the fact that this would have been another like probably 5 years of research just for me, but given the fact that for the continents, I didn't have an estimate of the plastic exposed to UV, the polymer types, the surface area. I could not extrapolate the numbers for the total amount of greenhouse gases produced by all of the plastic on Earth. So I mean, ultimately, I wanted to be able to tell there's a significant difference, and the plastic is contributing by this much to climate change. But because I didn't have these accurate numbers for the land, I had them only for the ocean because admittedly we studied more plastic pollution in the ocean than on land. Then I could not extrapolate the numbers to the full Earth, if it makes sense. But yeah, I just wish that there will be a full group working on that estimate one day so we get a better understanding, and then it will hopefully push law and policymakers a bit more. But yeah, I only know that 1.5 teragram for the ocean plastic.
Última pregunta.
Hola Sara, ¿cómo estás? Muchas gracias por tu presentación. Mi pregunta es un poco más personal. Quería preguntarte cómo lidias emocionalmente con todo esto que aprendes y que conoces y que descubres, porque en lo personal es bastante abrumador y de repente bastante desesperanzador. Y entonces quería preguntarte porque, no sé, incluso con cada pregunta que te hacían era como, oh, Dios.
Yeah.
No sé si hay salida de esto. No creo que sea la
Sí.
respuesta, pero quería preguntarte cómo haces.
Yeah, no, this is a great question, and you're right. Like 10 years ago, when I started this research, I was really affected by it because I was doing beach cleanups during the weekend, and I would do my run and pick up trash along the beach, and then I will work on the topic. So my whole life was basically about like studying plastic pollution, trying to stop it or make a difference. And at some point, it's a little it really like it gets to you, but in the end, I mean, for me doing research really helps me like balancing that lifestyle because I'm doing my share, and I think the feeling is the same as a consumer. It's like if I feel good about all of the small differences I make every day about it, then it helps like having a better feeling about it. And I can see like going to a beach cleanup is so rewarding. Like when we finish 2 hours of cleanup and we have all these pickups full of trash, and you discard them in the proper way or you reuse them and you make art out of it, it's really fulfilling and it gives hope. That being said, I would never stop the research on plastic because I think that's the only way of proving like the toxic effect of it, even though I mean, it will always be like, it's like if you keep smoking and smoking, it will never get better. So until we stop consuming plastic or we reduce its production, then we just keep on finding more negative effects. But I believe in us. I believe in the humanity and our next generation. Like I see it with my daughter. I mean, she comes to beach cleanups. She loves it. She picks up trash, sometimes too much. So have to be like, okay, we are going from point A to point B. We try to not stop. Sometimes it becomes a little bit like too much, but yeah, I believe then with the future generation bringing more awareness, having all of these talks to a general public, to research, will help with time, and I believe it will make a difference because we can keep doing this, and with the new technology and new materials coming out every day, I think at some point there will be a shift because otherwise we are intoxicating and the planet completely. So I still have hope. Otherwise, I think I will be really depressed on a regular basis. I believe in us and in human beings to fix their mistake, basically.
Vamos a dar por finalizado el espacio, ya llevamos 1 hora y estuvo muy bueno que hubo ya tantas preguntas en el público. Vamos a agradecer otra vez a Sara.
Muchas gracias.
Y espero que hayan anotado su mail y le pueden preguntar cualquier cosa, si no, me lo piden a mí. Muchas gracias, Sarah-Jeanne. Me alegra
Muchísimas
verte.
gracias. Que tienes un buen día.
Igualmente.
Hasta luego. Chao.
Y esperen que les anuncio ganadores de los premios.